Okay, here's some things you need to know before you can take these derivatives. And there's also some identities you need to know before you can get the answers that you have listed here. Okay, so the derivative of hyperbolic sine is hyperbolic cosine, and I'll let you read the rest. So for number 5, we have 1/2 times the derivative of the hyperbolic tangent of 2x. Derivative of hyperbolic tangent of anything is secant squared of the anything, which is right here. And then we have to use the chain rule. The derivative of the inside is 2, and 2 times this 1/2 is 1. That's why we get this. And then the derivative of hyperbolic cotangent is minus hyperbolic cosecant squared. And then there's the chain rule, and 3 times 2/3 gives us this 2 in front, and there's a minus here. So there's your answer right there. Number 6, it's a little easier to see if you picture this exponent of 2 up outside the brackets here. And then we apply the power rule, moving the 2 down front, leave the inside the same, reduce the exponent by 1, then multiply by the derivative of the inside. Well, the derivative of all of this is, well, the derivative of hyperbolic sine is hyperbolic cosine of the same thing, but then we got to multiply by the derivative of the inside, which gives us the 6x. So it looks like the answer might be 12x times this, but there's an identity that's similar to, whoops, this is supposed to be hyperbolic cosine, similar to the double angle formula for trigonometric functions, sine of twice an angle. So this 2 hyperbolic sine of 3x squared minus 1 times the hyperbolic cosine of 3x squared minus 1 is the same as, whoops, I didn't want this 2 here. In other words, we're going from here this way. So we want the hyperbolic sine of twice the angle. So there's twice the 3x squared minus 1, which gives you the 6x squared minus 2, the 6x out front. Okay, and let's see. I wanted to paste something on the second board here, which I forgot to do. And copy, so bear with me. Go to board 2. And we'll come back to that in a minute. For number 7, you have to know that the derivative of arctangent is of something is 1 over the something squared. So there's the something squared. Times the derivative of what's on the inside. The derivative of hyperbolic sine is hyperbolic cosine. Got to multiply by 6 because of the chain rule. And then there's a identity that says 1 plus hyperbolic sine squared is equivalent to hyperbolic cosine squared. And then one of these factors cancels out, and the reciprocal of hyperbolic cosine is secant of 6z there. Okay, and I just wanted to come to this board and show you how you can kind of check your work on Desmos. Here's the original for that second. If you graph f prime of x, you get this red dashed line. And then here's some intermediate work. As g of x is 12x. That's what we got before we applied that double angle formula. Same exact graph. And q of x is rewritten using that double angle identity. Same exact thing. Okay, there you go. Hope that helped. If you have any questions, post a comment.